All right. Um, yeah, there's a bit of a latency issue. I'm gonna go ahead and just fix that real quick before we get started. Seconds. Um, there is no one on the network but me. So just give me a second. All right, let's see how that rolls. Looks good so far. No dropped frames or anything. I think we're doing okay. Okay, let's get on with the show. Yeah, right now we're in translunar coasts attached to the lunar module. How's everyone doing tonight? Yeah, sorry I didn't do anything for Artemis 2, but honestly, I was watching that with people and I was just having a good time with that. I didn't stream anything really. I didn't want to capitalize off of it. I was just happy to be, watching it with people that I enjoyed doing space stuff with, and I would much rather be doing that, watching that with my family and my friends than I would be streaming. So that's what I did. And I took a time to, help some friends learn NASP. Took some time to talk to people in the reentry Discord. Um, so yeah, had a good time. Met some cool people, chatted it up. You know how it is. I get distracted like that. It's very, very easy to get distracted like that. So let's just get a roll on here. We're currently at T plus 3 hours, 38 minutes, and 57 seconds and counting. Let me know if I need to adjust any volume or anything. It looks like I'm near peaking out here on my mic volume, so I'm going to go ahead and dial that back a bit. And to compensate as well, we'll also dial back the desktop audio and let me know if I sound good. If I don't, then I'll restart my audio drivers, but just let me know. Give me a shout if things sound like dog wash, because you guys know what it's supposed to sound like. So yeah, just let me know. Our next procedure starts here in about 5 minutes, so we'll go ahead and do some light time skipping. And while we're doing that time skipping, let's go ahead and mount our covers for our altimeter and our G meter. S4B doing some venting. Yeah, we're booking it away pretty fast. Fairly fast. Apollo 10, so we're not going to be landing on the moon, but we're going to be doing some absolutely amazing sightseeing from orbit. We're going to get really close to the surface and then really, really high up. Apollo 10 actually holds the record for the highest orbit above the moon that was in a stable orbit. So not a circumlunar flyby. Okay, Artemis 2 holds that record. But Apollo 10 holds the record for the highest altitude crewed vehicle above the lunar surface. So we're going to see some cool stuff, irregardless of the fact that we're not landing. High O2 flow, that's perfectly fine. Verb 48. Let's get our digital autopilot running up. So we load a 2 in that first register for the fact that we're on a CSM and Lunar module. 1101, 4-jet translation. Error should be 0.5 degrees and a rate of, what was that, 0.2 degrees per second. Enter. Throw through that extended verb, and then verb 46 will activate that load. We'll go ahead and get our EMS set up for undocking. Verb 6, noun 22, enter. 1 TVC servo. Sequential events control system pyro logic is on. We will get the go for pyro arm from mission control, so pyrotechnics are armed. Verb 66. DET stop and reset. And we'll go ahead and we will load program 47 coming up shortly. We'll go ahead and wait on that just a little bit. LEM ejection happens at 4 hours 9 minutes. We are currently at 3 hours 48 minutes. Still the high O2 flow, but it looks like we're having a little bit of a high suit's cabin delta pressure, so most likely we're doing some purging of the suit line. The reason we're holding off on program 47, despite the fact that it wants us to call it now, is because we will accumulate errors if that program is running for several minutes beyond what it's supposed to. The PIPAs are extremely accurate devices. Those are pulse-integrated pendulous accelerometers. They're extremely accurate. However, over larger periods of time, they can build up inaccurate readings, so they can count inaccurately over larger periods of time. So we would run program 47 about a minute before we would start a procedure. We are currently booking it away from the moon. Altitude is currently 23.4 megameters. You can see the high O2 flow has gone out. We've got a normal O2 flow now, so nothing to worry about with that. Sometimes we get that alarm. It's a fairly normal one. O2 flow high by itself is not really a stress. It's when it's, paired up with something like cryo pressure or fuel cell 1 through 3. Then we will have some suspicions. Or O2 flow high and suit compressor light could indicate that there's a leak and the emergency pressurization system is trying to keep up. So, 2 lights paired together is really when we start needing to worry. But the O2 flow high light alone just could indicate a cabin pressure cycle, a suit loop purge, that sort of thing. So not really a rise for concern, especially when we're going to be supporting the LEMS pressure now coming up shortly. We've got it secured right now for undocking, or for ejection, that is. "20 seconds to eject." Okay, mark.
Rotation, translation.
1, 2, 3, and stop. Okay, CMC auto. Go ahead and write that translation to our state vector now. And we've pulled away from the booster. Go ahead and maneuver to our docking attitudes here. Safe the pyros, safe the logic. Can even pull those circuit breakers. And we will no longer need the S4B LEM-SEP circuit breakers. And we'll turn the EMS off. Okay, SPS evasive maneuver is coming up now. So let's go ahead and get that keyed in. So we're going to do a really small firing of our engine, about 3 seconds. And this is to evade the booster. The booster will do its own maneuver to insert it into a orbit which will do a gravity assist around the moon and slingshot it into a solar orbit where it will be forever out of our way for the duration of this mission. And Apollo 10, if I remember correctly, it was Apollo 10 that had the mistargeting. Well, I don't want to go and say mistargeting, but there was an issue with the S4B slingshot maneuver, and it actually reaches an orbit which crosses one of Earth's Lagrange points and goes into solar orbit. But every once in a while, it re-enters Earth's sphere of influence and does a flyby. And it's actually something that you can occasionally see with a telescope. And in about, I want to say about a decade now, a decade from 2024, so about 2 years ago plus 10 years, so 2034, I think is the time where you can bust out your telescope and get a shot of the S4B doing a flyby in our sphere of influence. So really cool. You know, kind of a shame that there was an issue that caused that with the S4B, but not really a shame that it's you know, something that we can observe for the rest of time. We should be seeing the booster. Yep, there she is. I do not think we'll be able to see the booster for this burn, but she is there. We can see that nice green glow from the docking target on the lunar module. So if you're wondering how a nighttime docking might fare, there you have it. Really easy to target. And there our maneuver is complete. We will hit enter, clear that out.
Rotation.
Do a verb 37, enter, 30, enter. Time of ignition for this burn, since we didn't get it uplinked, that is 4 hours, 39 minutes, and 11.85 seconds. You can see that here under the section marked noun 33. Proceed. Onto the section marked now in 81 will give us our delta V. We can see it's a really, really small burn. But despite the fact that it's a small burn, we will be burning for 3 whole seconds. And that just goes to show the weight that the lunar module adds and a full tank of gas in our SPS. Really, really high weight vehicle, the LEM is. Extremely light compared to the command module, but a fairly heavy vehicle. So we really got to push when we've got a full tank of fuel with the SPS. That weighs a lot as well, so I would say that that's a majority of the weight, aside from the dry weight of the spacecraft, that fuel, in terms of consumables, is the heaviest thing in the SPS. SPS fuel is the heaviest thing for the consumable side. And so, to start, you know, it is not a particularly fuel-efficient engine, but as it gets lighter, it gets really, really efficient. And we'll see that as we come home. So yeah, it's, you know, a lot of people are sort of coming from KSP, and they're coming from that I have this delta V mindset, and that is certainly true. That's certainly true. That, you know, there is a fixed delta V, but then you also have to consider, as the fuel runs out and you get lighter, how much more efficient are your engines? How much more efficient even are your RCS? Maybe the requirement for an RCS burn on the way home, the delta V requirements for performing the RCS burn over the SPS, you can support a lot more delta V on the RCS, you know, coming home than you would going to the moon. So, in terms of a realism, KSP, I think it does a pretty good job at that. That is one of the things that, with mods, can be simulated. And it doesn't play like a huge effect in flight, but for mission planning, that's a really big thing. You know? It's a really big thing. Imagine the planning that went into budgeting Apollo 7, having like 2 drops of fuel. You know, 6.8%, I think, is what it launches with, of fuel in the SPS. That engine is so efficient with that little amount of fuel. And that allowed them to put this thing on an S1B. So, that type of mission planning is huge. So, not an overall huge impact on the flying, but really big on the planning. What's going on, Dotson? Great to see you here. We are maneuvering to our separation attitude, which I thought we have already maneuvered to, but we may have keyed in something a little bit wrong. Just taking a guess, because these angles here are reading very close to the pad angles, so we might have mistyped, you know, put a 4 instead of a 5, and it was pitched that we were off, and so might have accidentally typed in 247 instead of 257, or, you know, that sort of thing. But that's why we like P40. Like I said, computer has never done me wrong. All right, anytime something goes wrong, it's almost always user error, but having the faculties to correct user error is one of the reasons why I recommend flying Apollo 7 and Apollo 9, despite the fact that they're the hardest missions of the available ones. Apollo 9 may be the hardest overall mission. I still recommend it, because you get all that technical knowledge and the backup stuff, so definitely, if you haven't, give those a fly. And I appreciate the compliment. It's a pleasure to see you here today. Getting ready to perform a check of our thrust vector control. I'm going to go ahead and recenter the gimbal angles here. T-minus 5 minutes to the evasive maneuver. We'll go ahead and start pitch motor 1 and yaw motor 1. Turn the handle to engage SCS without flipping the switch. And we verify we have no manual thrust vector control. That's perfectly good. Computer runs on 1, SCS runs on 2. So we start group 2. There's pitch 2. There's yaw 2, making sure to hold it for at least half a second. Give a test of our trim. Down, up, left, right. And let's take a look. We need to load in 0.9, so that's 1, and then we'll subtract 0.1, and then minus 0.2. Perform that gimbal check. Pitch up, pitch down, center, yaw left, yaw right, center, and we have the time to show it. Here you go. That's what that looks like from the outside. So we can see we're gimbaling the engine. This is what gimbaling means. DHC neutral. That gives it back CMC control. AC-DC. Switching to AC allows you to only control the engine, whereas AC-DC gives you hybrid control of the engine and the RCS. Proceed, and the computer does its own check of the engine. What's happening, Yamaha? Yeah, we could see a tiny issue with the trim here that we're going to go ahead and correct. Plus 00090, enter. Plus, or excuse me, minus 00020, enter. Proceed. And then we will go ahead and we will recall program 40. With the new trim angle, we get a slightly different attitude. How long have I been live for? Let's see. We've been live for 34 minutes. And there we go. That's our correct angles here. Limit cycle off. 50-15. T-minus 2 minutes. We'll go ahead and we'll arm bank A. And this burn will be performed only on bank A. It goes good. Yamaha, it goes good. Thanks for asking. At T-minus 35 seconds, we could see a little bit of an interesting angle for our evasive. But at T-minus 35 seconds, we'll hit average G mode, and our PIPAs will turn on, signified by the blanking and redisplay. EMS will go normal. No ullage is required because we have enough fuel that we don't need to worry about slosh and the fuel getting out of the fuel lines and all of that jazz. So that is not of concern for us. 9, 8, 7, 6, 5. The engine enable verb. We'll go ahead and confirm. Ignition. 2, 1, shutdown. And that is all she wrote. There's our evasive maneuver complete. Banks off. Gimbal motors off. TVC servos off. And main battery ties off. Proceed. Residuals look good, and there will be no reason to trim. VMAG set rate 2, added to deadband max. Translation controls off, direct power off, and we'll go ahead and pull those pitch and yaw circuit breakers. Good results for our burn. Proceed. 0, 0, enter. Verb 66 copies our primary state vector to our backup state vector slot. And let's go ahead and start a charge on battery A. The S4B is going to be performing its slingshot maneuvers, so let's go ahead and take a look at that. Go target, vessels, S4B stage, apply. And there we go. There's our spacecraft. We can see we've basically slowed down our forward trajectory a little bit. So we've built up a lot of differential velocity here, and we are flying away. S4B will be starting its slingshot maneuver very shortly. And there she goes. This maneuver, since the S4B technically doesn't sport 3 ignitions, we don't talk about Apollo 9. Since she doesn't technically support 3 ignitions, this burn is performed by dumping the rest of the fuel, and all subsequent mid-course correction maneuvers for the proper S4B side of the mission are performed on these little pods mounted to the side called the auxiliary propulsion system. They're responsible for controlling the S4B attitude and for firing in the plus X direction, giving ullage to any ignitions or also performing small mid-course correction burns. When you can see this, I think Apollo 11 does the tracking of the booster as it does all of this. When you can see it, it looks like a kind of a gorgeous constellation. Let's see if we can't see it from, yeah, there she, or constellation, I meant comet. Kind of looks like a gorgeous, gorgeous comet. Just rolling on by there. That's the S4B dumping its fuel. And you can see, even though it's not actually burning that fuel, it is only ejecting the mass. It's not accelerating the mass in any way, shape, or form. It's still building up an incredible amount of delta velocity here. Like, that thing is, it is booking it. And that trail goes on for a long, long while. Eventually, though, the propellants spread out because of the vacuum of space, and all of these particles get atomized as all of the atoms are flying away. You can atomize things with a really, really high vacuum because there's no atmosphere for the gas to organize, to sort of pool together due to density. There's none of that. You know, all of space is a big vacuum. So as it comes out, it spreads really quickly and everything gets atomized, and you're down to individual atoms scattering by the time, you know, you get out to here. And we are coming up on the end of the dump now. You can see that stream is looking a lot less bright. We've dumped all the fuel. We're doing that small bit of cold helium dump now. Helium was responsible for pressurizing the engine. Yeah, booster dump you can see out the window. We can't on Apollo 10. Tracking the booster was not in its primary objectives. That was a Apollo 11 sort of thing that they had going on, but something we can see by the grace of simulation. Cold helium dump now, and that's going to terminate very shortly. And there's the end of it. Once that burn has reached its delta V, the remaining amount of fuel will be dumped in a non-propulsive manner, like you see here. Remaining amount of fuel and cold helium. And that would finish off the booster's primary objectives, possibly a few mid-course corrections. However, since we're doing a slingshot around the moon and an insertion into solar orbit, there will not be any mid-course corrections, so that completes the booster's mission. We're going to maneuver the spacecraft so that we place the optics line of sight here towards the Earth in preparation for a series of Program 23s, which we will not be doing. Well, maybe, but there's a real epilepsy risk, so I tend not to do them, especially live. We can see our beautiful Earth here coming up in the optics. Staring straight down at a little bit of California, a little bit of Mexico. What a beautiful view, as some famous poets say, in exchange for most likely not doing the P-23s. Again, due to the epilepsy risk of doing them live, I can't put up, an epilepsy warning. We will go ahead and we'll do the optional P-52. So here's one that is a completely optional one since we have no major maneuvers coming up. Verb 37, enter. 52, enter. Verb 22, enter. 3, enter. That's our refs mat option. So we will be torquing the IMU to align to the current refs mat that we have. Proceed. Proceed. Pick a pair will identify the stars for us. It should be able to do it in just about any attitude in translunar coasts, because in almost any attitude we can see some stars. It has selected for us Antares, one of my favorites. Take a mark. Yeah, this is a study level Apollo simulator. There is no flight simulator that is more realistic than this simulator. Well, except a class Delta or a level Delta simulator used to train airline pilots. There's no commercially available simulator that is more realistic than this simulator. Peacock, a second favorite of mine, just because of the name. I get a little bit of a chuckle every time I see it, because it's like, how the heck did that get named that? Don't know. There's our drifted IMU amount. And that gets us back. That was less than 2/100ths of a degree off. So very, very good accuracy here from our sextant. Ooh, a GDC align will be required. So we will go ahead and do that. Our GDC, or Gyro Display Coupler, serves as our backup. In case the IMU were to fail, we would still have a way to get our orientation. And as a matter of fact, there is a way to align this without the IMU at all. However, when the IMU is in operation, we simply align it to the IMU using this system here. And, of course, 180 degrees off in roll. My mistake. A very good alignment. Okay, next activities, P37 pad. This is a TLI plus 11 abort purpose. After that, we would be performing P23s, which I believe we will decide not to perform, just because I see a couple of new faces around here. Epilepsy warning. Can't really do that live in any particularly meaningful way, because of course people can join after I give the epilepsy warning, so we will be not doing those. So we will skip right on down to a mid-course correction 1 decision. You can see the Earth very slowly rotate as we time accelerate. It is a really, really beautiful view. we're going to switch over to my favorite coasting configuration. ECM bitrate is low. Very good. This is my favorite coasting configuration because I find the computer just likes to overcorrect a little bit when I time accelerate. For most people, it's not an issue, but it could just be, you know, a little bit of system lag from my computer build. I typically prefer the SCS over the CMC. In a few scenarios, I am a little bit nitpicky on it. One of those is docking. A lot of times docking will be specified that it should be done on the computer, but I just find the computer tends to be a little bit bouncy. So I like using the SCS. Ha! That's a good one, Yamaha. That's a good one. I see what you did there. Mid-course correction 1 has been scrubbed. Okay. I see what you did there. Okay, all right. With your cheesy jokes. Don't know how long I'll be doing this for, because I think Yamaha said he wanted to do some VR tonight, possibly, so don't know how long we're going to be doing this for. We'll go ahead and disable our evaporator now. We no longer need evaporative cooling, since we are in an area where we can get stable amounts of sunlight consistently for radiative cooling. So we'll go ahead and we will shut off our water flow, and we will pull open the steam pressure valve. So I'll have that open for just a minute. 37, center. And we'll give us a wastewater dump, as well as a good old urine dump. Wastewater currently sits at about 65%. If we take a look out the window, we can see the dump is happening. The urine tank does have a quantity, however, it's not readable by any instrument in the cockpit. Really, its quantity is readable by, well, the amount of piss in a bag. The bag is the visual indication for the bag's fullness. Not really something that we're you know, that we have modeled, and why would we model the relief tubing system? That's kind of crazy. So I just do the dump while I dump the wastewater, and that's how I keep the quantity low, because that quantity is a real quantity that has to be dumped. So dumping the urine tank right down to about 20%. Checklist says 25. I like to do 20. And we'll go ahead and shut off that urine dump valve. And configure for proper comms. We can see tape recorder forward, no tape motion. Let's give a command reset. Still no tape recorder forward. Okay, so we do have an issue with the tape. We'll go ahead and rewind the tape. That is most likely the issue. And there we go. Proper indication on the tape again. Our first failure, and it's not even a simulated failure. It was just kind of a talkback glitch. So time in the mission is from launch, T plus 7 hours, and we are already this far after just, well, about 7, 6, 5, 4, about, yeah, 4 hours after cutoff. 5 hours after cutoff. If MCC is scrubbed or can be made with PTC refs mat, click Pro. So it is scrubbed, so we will click Pro, and we are going to come up on the desired orientation for passive thermal control. So we're going to get ourselves a brand new refs mat matrix uplinked to our computer. We'll drive our IMU to an orientation that makes the orientation of the inertial attitude mean something relative to passive thermal control. So as we drift away from Earth, we will actually stop drifting, or we will slow down our ascent away from Earth. So the further out we go, the slower we ascend away from Earth. So that's the reason why it takes 3 days as opposed to 10 hours. We are ready to receive our RefSmat uplink. So go ahead and radio mission control, tell them to send it up. Watch those numbers come in hot off the line. While that's happening, take a sip of water. So, Daytosan, if there's any questions you have, feel free to ask. You said you watched my videos, but if there's anything that needs further clarification, let me know. If there's anything you find wrong, let me know. Of course, always open to criticism and being told to double check something. I've had to do that on a couple of my videos so far. So option 1 to realign the IMU. Go ahead and hit proceed. Could take this to CMC mode. No need to maneuver the spacecraft. I'm going to set the attitude set box 93.5. Uh, 359.9. And 31.56. GDC align. We'll do verb 32 to get the most updated angles and proceed. We are good for a course align. Proceed. Straight into the mark sequence. Should identify some stars. And Terry's yet again. Mark. Proceed. Star 41. Dobby. Mark. Kinda new? Well, good way to learn before you fly your first mission is to sit back, relax, and observe. 4 balls and a 1. One of these days, sports fans will get our 5 balls, but that day is not today. Proceed. We can see that teeny tiny bit of motion there. And irregardless of how well this is aligned, I always make it a rule that after every preferred alignment, we just go ahead and do the GDC align anyways. Just to make sure that it's in as best shape as it can be. There we go. Our repress package has filled up, and we can tell that because our surge tank pressure has finally come up. Oh, if you're curious about things that can be used by the sextant, we have a whole list of Earth landmarks that can be used. We have a whole list of lunar landmarks, but also we have each of the nav stars that are in the computer's memory, and even better, each of the navigation stars that can be inserted manually into the AGC that the RTCC has memorized and can pick from. I don't know why they felt the need to add so many in that particular spot. But it is crazy. It's like a giant web. Let's try limit cycle out, see how it does. I find it tends to really, really overcorrect. Yeah, BD roll. I find it tends to really, really overcorrect when you're lighter weight. Not in real life, of course, because there's no time skipping you need to worry about in real life, but in sim I find it overcorrects. But with almost a full tank of gas and the lunar module attached, would be nice to see how limit cycle actually behaves in this configuration. Does it save me fuel? Does it stop me from bouncing around where I have to exit time skip every once in a while to, you know, make sure I don't go flying off? Well, we'll see. Kind of a little bit aggressive on the RCS. No reason to vent the battery compartment. However, the checklist tells us to vent it anyways. So we'll go ahead and vent it down to 0. Terminate fill of the repressurization package. And we'll be on our merry way. Still pointing more or less at the Earth in view of the optics. The moon is very, very far somewhere over in this direction. It's almost always by the sun. It's quite difficult to spot it in this phase of the mission. Yeah, unlike Orion, we have fuel cells for our power. They're sort of the best of both worlds between a chemical reactor, technically. I know that's a bit of a overstatement compared to, well, some other chemical reactors that make like paint and hydrogen peroxide, but chemical reactor combines that with chemical battery. It is basically a big battery, really, and that powers our flight. We have to keep these cells healthy. They will have impurities in the gases, in the liquid consumables, and as those are evaporated for consumption, those contaminants get in the lines, they slow the flow down, ice as well, and you can really, really hurt the fuel cells in the long run by not doing the purges when they're scheduled, so always make sure to do them. Purge will basically flow a high flow, high pressure amount of gas through the line to just sort of clear anything up. A bit like a can of compressed air, you know, that's some of the best dusters, because you get like a microfiber cloth, you get a regular duster, and you dust it, and it's like, damn, it actually leaves behind a little bit of dust. But you take a can of compressed air, and you and it gets it all off. It's exactly what we're doing to those fuel cell lines. How long are we away from the moon? We are currently... Give me 1 second. Well, I don't know why my Space Digital's page is not working, but we're on flight day 1, so we're about 3 days away from the moon. We are waiting on a state vector update from Mission Control coming in. And we are ready for uplink. Radio Mission Control, tell them the computer is theirs. So Mission Control is currently updating our computer's knowledge of where we are positioned. and they build that out through a series of telemetry downlinks, through gimbal angle positions of observatory, radio observatories, through Doppler, high-speed radar, and they build out a accurate picture of where we are between the Earth and the Moon, and what direction we're heading, and how fast we're heading, and they send that to the computer on occasion. We can calculate that ourselves with P23, although can't do that because epilepsy. But we can also do that in orbit with P22, and that we will be doing a lot of coming up, so you'll see that. Presently 10 hours and about 30 minutes into the flight. Everything's still going smooth as butter. Mark on Antares. Next star identification is 40. Ooh, look at that. Lunar module RCS jet. Hanging out. Star 40. What have we got? Altair. Mark. Proceed. Proceed. And our score, sports fans, 5 balls. And IMU realign complete. Terminate the battery charge. No reason to vent the battery compartment. Look at that. When we see the moon just yet, I really can't see it. The moon's only about 3 times the size of Africa, so it can get really hard to see. I think that's it right there. There it is. Ah, man, that's really, really difficult to see. Couple of other planets vibing out. PTC refs mat was already uplinked. We'll hit fail on that, and we will continue our time skip and wait for preliminary advisory data from mission control. Mission controls, got our data. And these are situations where we would basically point directly at the Earth and fire the engine. About face, get us home type situation. Get the spacecraft maneuvering to passive thermal control attitude. You can see that happen externally. It'd be really cool if we could stick a camera somewhere on the spacecraft, just for cinematic purposes. We'll be maneuvering normal to our trajectory and perpendicular to the sun. That gets us the best orientation for sun coverage, and subsequently the best way for rolling around, keeping everything preheated but also cooled off. Okay, let's just check our digital autopilot. We will switch to BD roll because that is the better of the RCS jet configurations. At the moment, our systems Bravo Delta have more fuel than Alpha and Charlie. So we will go ahead and we will change that to 01111 for Bravo Delta on the roll axes, and 21101. So row 1 is good. Pro, verb 46, enter. We have already maneuvered to our PTC attitude. Maneuver complete, so we will disable lowest fuel adjacent quads compatible with DAP. Charlie Alpha. Charlie, I believe, is lower, and then that would mean I think Bravo is slightly lower than Charlie. I've ever played Spaceflight Simulator. God, no. So we will take off Charlie and Delta. Or, excuse me, not Charlie and Delta. That was Bravo and Charlie. Not a big fan of games like that. I don't play KSP either. Just not particularly good at KSP. And we are going to just basically hold our attitude here, let everything dampen out for 20 minutes, and I can't do any time skipping faster than this amount of time. Otherwise, there will be overcorrections, and we will actually introduce oscillations instead of take them away. So we will just have to sit here till that timer goes up to 20. Get everything as stable as possible. Yeah, unlike Orion, we'll be having a constant roll. Orion did this thing where it sort of just turned 90 degrees every once in a while, but we will actually be doing a constant roll, like some rotisserie chicken you put in the rotisserie machine. I love rotisserie chicken. It is so good, by the way. If you never had rotisserie chicken, shame on you. You are the nemesis of flavor. Hey, yo, what's going on, Owen Schnell? "20 minutes. No more jet fire either. That's a good sign. Pitch and yaw to Excel command. We'll go ahead and enable all of our RCS. Oh, I've still been doing NASP. I've just been doing it in reentry VCs. Just hanging out with a couple of friends, you know. What leg are we on today? We are just completing flight day 1 of Apollo 10. We're going to write our little erasable memory program for PTC. So the first thing that we do is we set address 1332 to all zeros, and that sets the hold flag so the jets will not fire. We'll go ahead and we will command a 0.1 degree per second roll by setting address 3125 to 3 and to 24400. There's a second register in this address. Verb 21, noun 01, enter. And we will set address 3176 to 35101. And we will take away the hold flag. So verb 21, noun 01, enter. Set address 1332 to 70000. And as soon as we push enter, boom, there's our roll. We'll let the thing dwell on this a little bit. Nope, Apollo 10. They got rid of it after Apollo 8 because it was god-awful. It was so bad, SCS PTC. It was so bad, they canned it immediately after Apollo 8. They do actually have it set up with a verb. Ooh, if Artemis was here, I feel like they might know it because I think they were thinking about flying 12. Verb 78, I believe, is what it was on Apollo 12. You can call verb 78 for PTC, and you can also call it for orbit rate. But it only moves the spacecraft at like a fixed, you know, degrees per second. When you get into those J missions and you get universal tracking, or excuse me, universal pointing on program 20 as opposed to program 20 just being for rendezvous, it was also used for universal pointing. And there it got so good that it wasn't just, oh, let's do orbit rate by a fixed degree. It was, we actually do orbit rate by measuring the local vertical based on our state vector. Like, it was getting so good. Yeah, it was getting really good. Some of the things that they changed for the Artemis ropes for Apollo. Oh my god. Like Minky. When I fly Apollo 15, you guys are going to have an absolute hoot with seeing the amount of things that have been improved and changed. There's even a gimbal lock avoidance routine. Yeah, there's even a gimbal lock avoidance routine. There's crazy cool stuff that they started pushing after Apollo 12. I really want to take a crack at Apollo 13 though. I really, really do, but I'm holding out for a little bit. Okay, we're gonna change our deadband here. $32.55, setting address 3255 to 3434, and that'll throw us up with a 20-degree deadband. And clear that out. This is a simulator. Give our cryo tanks a stir. Alright, waste stowage vent valve closed, so we terminate our cabin purge. Verify our pressurization. We're going to tank up cabin pressure to 5.7 psi. And we'll go ahead and just use the push to test method for this. No worry, suit compressor light, that's normal. Taking us up to about 5.7 psi. And we'll actually stop here because the cabin gets a little cold. As the cabin temperature comes back up, the gas will actually expand. Direct O2 valve is closed. S-band voice off. And switch to Omni Alpha. Wastewater dump. And we'll also go ahead and do a urine dump. And you can see, as I said, with the gas expanded, as the temperature goes up, we did actually overshoot 5.7. We're more at about 6, but that's okay. Wastewater dump complete. And we'll go ahead and terminate the urine dump. And there's our rest period. Yeah, if we wanted to, over time, this will come down. But if we wanted to, we could do the correction right now. 1, 2, 3, and shut. There you go. 5.7. Exactly as all should be. Throw out. There we go. And that starts our rest period. How is Orbiter 2024 and NASP? I feel like you said you were a beta tester for it. No. I am a test pilot for reentry. Anyone can be a beta tester for Orbiter or for NASP. So that's, you know, as a matter of fact, just by playing the game, you're a beta tester. So, but Orbiter 2024 works really, really well. Passive thermal control. On our way to the moon. Yamaha, you still in the chat? Just wondering, we are at the end of flight day 1. I know it's a little late. I was just wondering if you were still feeling VR, or because if you're not, I'll go ahead and I'll continue and I'll fly through flight day 2. But if you did still want to do that, now would be a good time to stop. You know, we've been streaming for about 1.5 hours, give or take, so it's a fairly bulky stream, and we're at a good stopping point now. So just getting your vibes on that. Oh, look at that. We're staring right at Europe, India, China, Japan, Korea, Australia, the continent of Oceania. I can see Spain in there, Portugal. Really hard to see some of those smaller countries. It's actually really hard to see Italy there. Wow. Wow, we are far. But yeah, this really is a worldwide effort, so special thanks should be given out, you know, to the people that developed the spacecraft in America, that developed small parts of it from Canada, assisted with our communications networks through, you know, Wymus, Canary Islands, parts of Australia, um, possibly even other countries' military ships out in the ocean, um, to the countries that mined the materials to even make the ships. So really a worldwide effort going in to do something like this. That flag there, that just represents the tip of a spear held up by a lot of nations. How long are we going to be on stream? Well, that depends. If Yamaha is feeling up to VR, now would be an okay time to stop. I'd be time skipping through the rest of the sleep period, but if he says, nah, it's too late, I don't feel it anymore, then of course, we will be stopping, or I'll do probably another flight day. So predicted time of lunar orbit insertion, by the way. When they were in PTC, did they use the high gain antenna or the Omni? Yes. "74 hours is when we'll begin preparing for lunar orbit insertion. We are currently at 17 hours, 33 minutes, 55 seconds and counting. Yeah, the answer to that is yes. It depends on the mission. Apollo 11 used high gain antenna. Apollo 10 is using an omni antenna. It depends. I believe Apollo 8 might have used the high gain antenna as well. But I don't remember. It's been a while since I've flown Apollo 8. Some RTCC stuff would be cool, but I put up a vote and I was like, hey, guys, should we fly RTCC? And you guys were like, hell no. So we didn't do it. You guys didn't want to see the numbers, so sorry, but eventually if we want to venture out of the territory of, you know, 7, 8, 9, 10, 11, and 12, we're going to have to start crunching numbers. Well, here's the thing. If we fly the second day, it's going to be like another hour and a half, and then I'm going to be real tired. So I think now is a good time to stop. I think now is a good time to stop. You do? All right. Well, I'll tell you what. How about this? I really want to do the missions that I have never showcased on here. Like, I realized that I've only flown 8 and 11 on my channel, and 12, 8, 11, and 12. And my favorite missions are freaking, or, and a 7, excuse me, 7, 8, and 11. My favorite mission's Apollo 9. I love Apollo 10. It's like my second or third favorite mission. And Apollo 12 is really cool. None of those. I've just been doing 7, 8, and 11 over and over again because every time I finish, they update something, and then I gotta make new tutorials or I want to fly it again to show off some cool feature that got added. So I'm like, damn it, we need to do the rest of these missions. God damn it. So we're gonna do the rest of them, and then we'll do the number crunching. That is what I have decided. That's ultimately, you know, then we'll do the number crunching, and I think we're going to start with Apollo 15. I already know how to do Apollo 8 and Apollo 11 RTCC, but Apollo 9 RTCC, absolutely the fuck not. Nope. Nope. Not a chance in hell. But yeah, and I can tell that it's getting late for people because I could tell the viewership is dropping off. So I think now is a good time to stop. People are kind of like, oh, it's getting late. So now is a fairly good time. I think it was a great time to start when I did, and it's a good time to stop now. Sort of keeping it at around an hour and a half to 2 hours is, you know, that's sort of where people's attention span likes to be at. So like the workload wasn't already crazy enough. Are you? Yeah, yeah, yeah. You should fly Apollo 9 yourself, and then you'll see why I'm vehemently opposed to Apollo 9 RTCC. Terrible idea. All right, we're gonna stop 15 minutes to the end of the sleep period. And that's gonna be us for the night. Checking everything out. We still got good RCS. Real fine on the RCS even. Barely now lower than the Alpha. Real fine on the consumables. Real fine on the CO2. Cryos. Good on the fuel cells. Good on the engines. We're having a great time. We're sleeping. And that is going to do us for the night. I hope you all enjoyed. See you guys around. Peace out.